A boy pushes a 10-kilogram sled at a constant speed by applying a force of 75 newtons at 30 degrees with respect to the horizontal. The sled is pushed a distance of 15 meters. We must draw a free body diagram and show all the applied forces, find out how much work is done by force F, find out how much work is done by the normal force, find out how much work is done by the gravitational force, how much work is done by the friction force, what the coefficient of kinetic friction between the sled and the surface is, and finally how much work is done by the net force on the sled. Given this problem, we can write all the variables that we know. First, our mass is 10 kilograms. Our force applied is 75 newtons. Theta is equal to 30 degrees. And our displacement is 15 meters. These are all the statistics that we know. So I'm going to draw the free body diagram. So first we have going down, we have the force of gravity, or mg, and then perpendicular to mg, we have the force of friction in the leftwards direction. Then directly above mg, we have the normal force, Fn, and then we have the force applied. In the rightwards direction. To figure out how much work is done by force F, we will use the work equation. The work equation shows us that work is equal to the force times the displacement times cosine of theta. Now we will simply plug in our values and solve for work. For force, we will plug in 75 newtons. For displacement, we will plug in 15 meters. And for theta, we will plug in 30 degrees. And simply by multiplying, we calculate that the work done by force F is 974.3 joules. To figure out how much work is done by the normal force, we will also use the work equation. Work equals force times displacement times cosine of theta. Now we will plug in the values. We plug in 75 newtons for the force, 15 meters for the displacement, and 90 degrees for theta because the normal force makes a 90-degree angle with the surface. Now we will multiply and solve. Since cosine of 90 is equal to 0, the work done by the normal force is 0 joules. To figure out how much work is done by the gravitational force, we will also use the work equation used before. Work is equal to force times displacement times cosine of theta. Now we will simply plug in our values from the problem. 75 times 15 times cosine of 90. Theta is 90 because mg also makes a 90-degree angle with the surface. And since, as we know, cosine of 90 is equal to 0 degrees, the work done by the gravitational force is equal to 0 joules, just like the normal force. To figure out how much work is done by the friction force, we will also use the work equation. Work is equal to force times the displacement times cosine of theta. Now, as we know from our free body diagram, the friction force is going in the opposite direction of the applied force, so therefore the friction force will be negative. For force, we will plug in negative 75 instead of 75. Plug in 15 for the displacement and cosine of 30 degrees. Now, by multiplying, we saw that the work done by friction is equal to negative 974.3 joules. Noting the negative sign here, we see that the work done by friction has the same number as the work done by the force applied, but it is opposite in direction. Therefore, the force of friction is equal and opposite in direction of the force applied. Now we must find the coefficient of kinetic friction, otherwise known as mu, between the sled and the surface. So first we will set up our work equation. Work is equal to force of friction times the displacement. Next, we will substitute the force of friction by writing work is equal to mu times mg plus F sine theta times the displacement. Next, we will plug in the work, which we saw before in the part B as 974 equals mu times mg, which we will do 10 times 9.8, which is 98, plus 75, which is the force, times sine of 30, times the displacement, which is 15 meters. Now we have one unknown, so we can solve for mu. And by dividing, we solve that mu is 0.48. Note that the coefficient of friction is a unitless quantity, so mu is simply 0.48. For the last part G, we are solving for how much work is done by the net force on the sled. Now, since the sled is moving at a constant velocity, work is equal to 0 joules. The net work is equal to 0 joules. Now, the work for this I will show below. From Newton's laws, we know that force is equal to mass times the acceleration, commonly F equals ma. Force equals the mass, 10 kilograms, times the acceleration, which is 0, since the sled is moving at a constant velocity. Therefore, the force is equal to 0 newtons. Now, going back to the work equation, work equals force times the displacement, we plug in our values. Work equals 0 from there, times the displacement, which is 15. Now, since anything multiplied by 0 equals 0, the net work equals 0 joules.